Hello everyone, welcome to the final day of the Metal Ops Smart City Hackathon. Let's start by giving a huge round of applause for all the incredible hackers, mentors, Code Metal staff that have been up for really 24 hours. So let's everyone give yourself a round of applause. Awesome. Very cool, very cool. So we're all going to be blown away by the amazing tech on display here today. But before we begin, we'd like to extend a heartfelt thank you to all the people that helped make this possible. We want to thank the United States Special Operations Command for providing all the resources to make this possible, our valued venture partners, J2 Ventures and Shield Capital, the City of Boston, the Steel Group, Mass Robotics, JP Morgan, and Rebuild Manufacturing. So again, thank you. And let's give a round of applause to SOCOM making all this happen. And again, to all the hackers that spent the last 24 hours advancing the mission that SOCOM set forth for Code Metal and its resources today. So again, thank you. So now on to the main event. Each team will have 4 to 5 minutes to present their projects, which will be judged on 3 criteria: impact, function, feasibility, and scaling. The 3 highest scoring teams will then face a final vote by the judges to determine first place, runner-up, and second runner-up. In the event of a tie, Code Metal co-founders Peter Morales and Alex Showalter-Bucher will decide the tie. So we're going to start with our first presenting group, Team 1, and come on up on stage. Watch the wires, guys. Okay. Watch the wires. All right. You guys good?
Oh, there he goes. There we go. Lovely.
Right. So we are Team 1, and we designed Guardian Angel. So the problem, decision paralysis. Pilots they're incoming all kinds of information, insane amounts of data, and they have to make split-second decisions. What happens when people are under fear? They're having fear. A natural human reaction to freeze up. And that's why in 2024, there was an average of 4 runaway near misses per day in the US. For fighter jet pilots, it's even worse. They have communications, tactical communications, threats from all over. It's a matter of life and death. It's only going to get worse with increasing traffic, drones, eVTOLs, autonomous vehicles, and that's why we designed Guardian Angel.
Thank you. Yes, the solution, what we're calling Guardian Angel. And we take in all kinds of data from the plane itself, GPS, ADS-B data from all the planes in the area, and even the raw noisy data from air traffic control, which we process using transformer models and natural language processing to turn that noisy audio into actionable data. And we build this compliance model. And stuff like not being alive or a high risk of not being alive are not compliant. And if at any point we detect that you are going to be non-compliant very shortly, we provide the pilot with an immediate life-saving evasive maneuver. They already have enough data. We don't want to give them more data. Hey, there's this, there's this. We tell them exactly what to do to stay alive. Now, the impact, we process this all on a Jetson Nano. We don't have a cable to hook it up to the TV, but it ran on that. So here, if I can play this, this occurred 2 weeks ago. We replayed it as if our system was on board. So, oh, okay. Nope. Hey, there we go. So we have this blue plane here that is told by air traffic control to turn left and then wait, because there's a lovely Southwest plane that is landing on this runway. Now this pilot, unfortunately, he's new to the airport. He's got all this stuff written down about where he's going to go, and as he approaches this runway, we notice he's not slowing down. And we issue an immediate alert. It might be loud. I don't know if there's audio. There's no audio. So we issue an immediate, audible stop, stop, stop. So he knows. If he hears that, he stops. He does whatever it says. Now, unfortunately, that plane didn't have our system on board. And we look what actually happened. It cut in front. Okay, this started late. There it goes. It cut right in front of that landing plane, seconds away from killing everyone on board if that plane had not noticed and pulled up. And that's just not acceptable.
All right, so TCAS is great as a collision avoidance mechanism if you're a commercial airliner. If you're a commercial airliner pilot operating at high altitudes. Unfortunately though, it is highly expensive, not for the general aviator, and it doesn't really work if you're on the ground or close to it. That's why we designed Guardian Angel. We wanted to build a system that not only had a cognizance of air traffic control intent, but also had everything you need at your disposal to deliver actionable information that a pilot can use to get out of any situation at their peril or need. Yeah, so also in the defense sector, we outfit fighter pilots with everything they need to. Okay, I guess timer's up. Thank you very much.
We can also do missiles. It's better, break left as opposed to stuff like that.
Awesome, guys.
Thank you.
All right, watch your step.
Awesome. I wish I could look at that one.
Excellent, guys. Okay, great. I also want to give a special shout out to Fulcrum Ventures. Andrew, who, raise your hand, Andrew. He's one of the first guys that we reached out to and really been spearheaded introductions to different VCs and supported us. So again, thank you to Fulcrum Ventures, really special. Okay, we're gonna go with team 2. Team 2. Pathio bin, yep, there you go, come on up. Watch your step. All right.
Sorry. Sorry about that. Where is the time?
I'm going
Is
to
there a
give you a
time?
1-minute warning and then tell you when the time is up.
Oh, okay, sounds good. Did the time start? Okay. Yeah, check out the notes for a sec. Okay. Good afternoon, everyone. My name is Romeo, and I'm here to describe PathoBin Protect. PathoBin Protect is a smart city solution focused on real-time biohazard detection in public waste bins. Our team, myself, set out to solve a critical urban safety issue, one that directly impacts public health, emergency responders, and national security. Imagine you're walking down the street, let's say Boston, for example, passing by a public trash can. You don't think twice about it, but what if that bin contains hazardous materials, things like contaminated needles, using PPE, or even biological threats? The reality is, waste burns in urban areas have become unregulated dumping grounds for dangerous substances. Current waste management systems lack real-time monitoring, meaning these hazards go undetected until it's too late. This isn't a public health risk, it's a security risk. If a bioterrorism attack were to occur, waste bins could be an easy and undetected delivery system. That's where PathoBin Protect comes in. Our solution, we developed a compact, low-cost IoT sensor device that attaches directly to public waste bins and detects hazardous chemicals and biohazards in real time. The system alerts the city officials, emergency responders, and even special operation teams to ensure rapid response. Our device integrates with existing city infrastructure, including IoT platforms like AWS and Azure, as well as city traffic cameras. Unlike traditional waste monitoring solutions, our system is designed for early detection, identifying potential threats before they were major public health crises. Impact. The impact of PathoBin Protect is far-reaching. First and foremost, it enhances public safety by detecting and mitigating biohazard risks before they spread. It also protects waste management workers, emergency responders, and city personnel from accidental exposure to harmful substances. Beyond safety, our solution contributes to urban resilience against bioterrorism, an area where smart cities currently lack proactive solutions. And from a financial standpoint, it reduces emergency response costs while making waste management operations more efficient. Target audience. Our primary users include city governments, emergency response teams, and DoD agencies responsible for urban security. Additionally, smart city initiatives and waste management companies stand to benefit from integrating our technology into their existing systems. Ultimately, the technology serves everyone in urban areas by making public spaces safer and more secure. To bring this idea to life, we used an ESP32 LoRa V3 microcontroller paired with an MQ2 gas sensor to detect harmful gases and biohazardous aerosols, for example. Our software stack includes C++ and an Arduino IDE for firmware, incoming AWS IoT Core for cloud integration, and an incoming React Native for a mobile dashboard that provides real-time alerts to stakeholders. This setup allows for low-power, long-range communication, making the system scalable and cost-effective for cities across all sizes.
About 20 seconds.
That's it.
We forgot to mention this, but there's about 1 minute for questions where it's
Oh, that's
live,
fine.
so
I
if
can
you
answer
have-
questions.
Yeah, if you have
Wait,
any
did the
questions-
other team answer questions, or? Oh, that's the remaining timing, correct?
No, we should have said that the first.
Oh, okay, that's fine. Is there any questions?
Yeah, can this be carried on a person's body?
We haven't thought of it, but in the future, that could be definitely viable. Yes.
Where is it and does it work?
Say again?
Where is it and does it work?
It's over. I didn't think I was going to be presenting it. I would have to run, but that's going to be like 2 minutes. So.
Does it work?
Yes, it does, but it's focused on different sensors, not actual biohazardous sensors. So.
And let's give them 1 minute for the question.
Okay,
Right.
Is
So
that-
if there's any question for the first team on Guardian Angel, we forgot to mention.
Thank you. Appreciate it.
Please ask them.
Sorry, we're back. Any questions about Guardian Angel? Yes?
What systems would you integrate with?
Sure.
GA?
So, I mean, in the general aviation community, at least me, I got my phone mounted on the cockpit. Everyone I fly with has got a phone or iPad. We can optimize this to the point where it's an app you install, or we partner with ForeFlight, got working on that, on slightly nicer systems. You look at glass cockpits, Garmin, you can get something integrated there. Any other questions? Going once, going twice? Sold.
All right, thank you.
Thanks, guys. All right, bringing up our next presenter. Team 3.
All right, hi everybody, we're Team Medeiros, and this is Project Lantern. So our problem statement, I'm going to get right to the bottom line up front. Lantern piggybacks on existing passive systems to covertly track vehicles and persons of interest. By leveraging signals already emitted, but not fully utilized in the urban environment, we can create a low-profile, wide-area surveillance web with ultra-low size, weight, power, and cost considerations. So what is our solution? We're exploiting tire pressure monitoring system data collected by our sensing nodes. That's being passed through our mesh network hidden in everyday objects discreetly. It's being combined with unsecured traffic camera data, and that's all being processed into discrete vehicle profiles, which are being used in our command and control center to track all vehicles in a city. So what do I mean when I talk about a lantern node? So this is a traffic camera right in front of Boston Common, just a few blocks from here. And you'll see I'm in the picture, and I'm holding a Dunkin' Donuts mug, which is really a lantern node. And what goes into a lantern node? 4 things. Only things that are needed are a microcontroller and a LoRa module, a TPMS sensor, and a battery. Really simple, you've got a node. Pair that with the traffic data. You're now receiving RF signals from all of your tires passing by, and you compare that with license plate recognition, other forms of image identification to create a vehicle profile. So we're taking all this data that's freely available, it's unsecured, pretty big exploit that's been known about, but not really taken advantage of until now. Combining that with our image recognition, doing some data processing.
Right, so with all of this data from this mesh network, so how do we actually use this? So in a sea of Toyota Camrys within Boston, how do we triangulate which sensors belong to which Toyota Camry? So our solution for that was to match tire sensors to particular cars. You construct a graph where the nodes are the unique TPMS sensor IDs, and the edges between 2 nodes are the number of co-occurring detections between a given time threshold for 2 unique tires. And so what we do is we can match tires to particular cars by forming these cliques of size 3 to 4. And the objective is to maximize the sum of these edges. And we can also generate confidence score for a given click for how confident we are that these 4 sensors belong to one given car.
Sure. So why does this all matter? So earlier we showed we had a node over by Boston Common. You tracked some vehicles there. We found a vehicle of interest. We then had it ping over at Haymarket. There are no traffic cameras at Haymarket. We are able to detect where that vehicle is moved without any external data. They don't know they're being tracked right now. As far as they know, they're driving on a road with no cameras or other detection abilities. So this is really cool. We can passively track every car driving around Boston with our nodes. I got 22,000 steps this weekend putting nodes all over Boston. Great exercise. But we can do more than that. So we set this up with a modular open system approach where we have standard inputs and outputs where you can add more. So in this example, we did a prank on our friend when he drove by one of our nodes. We did a low-power passive FM transmission of a popular song to prank him. He changed his song on his radio. This is big impact. This vulnerability is on all modern vehicles. Our bill of materials is less than $7 per node, and our power analysis indicates this can last for 425 days on a single charge. So set it, forget it. If it breaks, no big deal. It'll last. Our target audience is dual use. We have Special Operations Command, which has very obvious use cases for this, as well as the intelligence community, and smart cities who can non-discreetly install this in telephone poles, things like that, to use it for crime scene investigation and evidence gathering, emergency response, and precise vehicle tracking there. Our stack, we've been updating our nodes to lower our size, weight, power, and cost while increasing our technical readiness level for a hopeful actual operational demonstration in a special operations environment. Pretty standard data processing stack as well as command and control using Next.js. And that's our team. We had a lot of fun, not much sleep.
And while we were doing this, we also have live data from outside the building. This is the cars.
We're broadcasting the cars right below us right now.
Yeah, this is it.
Any questions?
Any questions?
Yes.
What kind of node density do you need to be effective?
So the node density matters what type of continuity you want. So we just had 4 nodes at a time. Our max was 5 nodes just due to limited hardware. We had a 92% detection rate. However, as node density increases, you get much more accurate data to where exactly on the street are they versus, hey, if they hit this intersection, they hit that intersection. So it really matters what type of granularity you want.
exploit your node's RF signatures?
Yeah, so we get a ton of metadata from what we're receiving, and we are processing that. I think we can go to our example.
What is your node emitting?
Oh, so we are using,
So basically, it's doing LoRa. We built this over Meshtastic, which is a publicly available open source LoRa sort of mesh network. So our data would basically blend in with, someone's IoT sensor for flowers or anything like that, and the data is encrypted, so they don't know whether it's DPMS signal passing or flower
smart
data.
fridge. It could be anything. The data is not suspicious at all when you look at the spectrum.
Excellent. Good job, guys.
Thank you very much.
Watch your step. Watch your step. Great job, guys. All right, bringing up Team 6.
Oh, there were 2 Team 6 submissions, so make sure you know which one it is.
Resilient Mesh Evolved.
Yeah, that's us.
Pick up.
Okay. Well, hi, I'm Jacob. I'm from Arachna Networks, and my FAU team comes from Palm Beach County, Florida, and we are excited to compete in this hackathon and show how metal we are and act out like cyberpunks. We often go around our city testing the different technologies, seeing what kind of fun stuff we can hack into, like our beer wall, getting free beer at our local pub. But there's one thing that we came across that was so dangerous for our smart cities and our military that left them vulnerable for attack. And what I'm talking about is, communication marauders. So take a look at this video with a small device that's handheld. You can shut down entire zones of networks and disrupt all the devices. So this will stop your workflow, all your network data, but more importantly, your security and the systems that keep you safe and the cameras that keep you safe. So what do you think a bad person or a group might feel empowered to do if they know they can shut down your cameras to your house? What about to a government building or a city building? What if it's used on our own military? How could they be exploited by individuals that can disrupt systems covertly? That's why Arachna Networks is... That's why Arachna Network is coming up with a solution to fix the gap in this security, to save lives, and create a new standard where the future remains safe. Our solution sets the framework for secure camera systems with an arsenal of dynamic backup emergency channels, and here's how it works. You have your camera system working fine, and here comes this marauder along that activates this device, attempting to bring down your system. Your network will alert you of this attack and utilize a backup mesh LoRa channel to keep data flowing for visuals so you know what's going on so you can mount a proper response. The great thing about our technology is everything is highly obtainable, and we use a dynamic interloping mesh system that ensures every device always has a robust condition, no matter the scenario. Having every type of connection at your device and your disposal while being decentralized gives you the highest chance of remaining connected with all different devices out in the field. The heart of our system is Reticulum Network, the most powerful open source mesh network tool designed for a wide variety of communication modes for universal mesh communication framework. We want to ensure that we're using our LoRa channels properly. We filter the images using Brisk and use object detection like YOLO to select quality images to use the LoRa network efficiently. And our target audience for this is... Our target audience for this application includes smart cities and the military that want resilient connections for their camera systems, and even serves as a multifaceted solution to create resilience against environmental factors that can disrupt large sectors of infrastructure. This technology can rapidly integrate into new systems with the framework of our solution, making a real impact to save lives before it's too late. So now we're going to play a little live demo here, and you can see how the system works. I'm a Windows guy. I love clicking on a Mac sometimes. There we go. So we have our Wi-Fi stream going up. As you can see, the video on the right has frozen, and the video on the left still has clear video, but that means it's not streaming anymore. So then we utilize our backup LoRa channel, and that will send through picture images of the best quality available, so you know what is going on when your systems are attacked. And thank you.
Questions? Any questions?
Oh, questions, open for it.
What kind of bandwidth do you put through it?
Well, that really depends. We can use, like I said, we can use all the communication modes available on a device. But with LoRa, it depends on line of sight and the different spread factors on how you transmit. So we have other applications where we did live voice video, and specifically for this one, we just have to do like physical testing out in the field and record those numbers. Any other questions?
LoRa is usually characterized by having like a very low throughput. How do you sort of do it with the IC so you succeed at that?
Yeah, so like I said, we're actually using highly selective images. We're using a program called Brisk, which then samples the images from the video sender and picks the best frame to send. So we're using the network efficiently, and then object detection to capture like objects of interest and use that. Any other questions?
Great job.
Thank you.
Great job.
Bringing up the vast vision. All right, how about a round of applause for these guys so far, huh? They're doing great.
Thank you. Before we start the timer, let's make sure this is in presentation. There we go. Great.
Hi everybody, my name is Kyle Gwynn. I came out to this hackathon from New Mexico. Spent a lot of my time inside of the Department of Energy complex, but it's been a pleasure to be here in Boston. So one of the things being in the Department of Energy complex that I've noticed is that there's a huge threat to national security, public health, and economic stability whenever it comes to tracking nuclear materials and radioactive waste. So my favorite story I'd like to tell about this is the kitty litter story where somebody mixed in the wrong cat litter inside of a container of nuclear waste as a byproduct from a weapon. This caused an explosion of that container at the WIP plant in New Mexico, shut it down for 2 years, cost $500 million to clean up, and 21 people had extreme radiation exposure. The most recent incident being in December of 2024, where some very low-grade radioactive waste went missing in New Jersey. Triangulate that with the drones that were flying around at that time. You have a public crisis, and that waste has yet to be located. And then the final thing is, as we start to bring more and more nuclear energy online, there's about to be a ton of nuclear material just floating around the private sector that could fall into the wrong hands of people. So my idea to solve this actually originated at Sandia National Labs, where they had developed a passive rad-hard sensor that will essentially be able to use for chain of custody and stability monitoring of nuclear materials and nuclear waste. So the benefits is it's rad-hardened, it can be used through metal, has multi-sensing modality, proof of authentication, immune to long-range RF communications, and easily concealed, not canceled. Sorry for the typo. So my idea for this hackathon is, what if we built out a smart city infrastructure for this that essentially allowed us to deploy stations, deploy antennas at our way stations, at our ports, at our bridges, all across the cities, all across the highways, And as nuclear material moves around with these tags on it, we can see the movement of it and we can track it, and then we can monitor its stability even when it's in facilities and moving around through our cities. So the impact that this can have, that $500 million incident could have been prevented. Things like the Hartford site could have been prevented. The total economic impact of nuclear contaminations is close to $1 billion or $1 trillion. But I think we got to stop. That. So national security and accountability. Essentially, we can track these things when they go missing. We understand the chain of custody behind it. And then the final thing that we can do is locate potential missing nuclear materials, just as long as it's passing through our public transportation. Public perception, nuclear has a bad rep right now. If we're going to be turning that on to increase our output of energy to solve the energy crisis, then we're going to need that. And then the final thing is improving public health. There's been 40,000 people who have taken advantage of what's called the Radiation Exposure Compensation Act, who have all been exposed to radiation. And then I guess number one, built an antenna out of an old stereo for these chips. It's kind of cool. It utilizes the magnet of the stereo and then generates an AC magnetic field. And then you would essentially put a magnetic resonator in there, and then you'd be able to get a response that would be turned on to an ESP32. And then I guess the final thing that I'll talk about is the actual interface for this. In my last second. So I think the biggest thing that we need to do is I kind of mapped out Boston, and then we're able to tap into kind of the existing city infrastructure, the live cameras, and triangulate that with the trucks that this is moving on, and just have a whole holistic overview of our nuclear material moving around our communities and our cities. Time's up. Any questions? One in the back.
So you've been looking at like kind of checkpoints and as people are leaving waste facilities and stuff like that, it affects exactly key points in the city.
Yeah, that's exactly kind of my idea, right, is we can place these at the ports, we can place them at airports, we can place them on bridges, we can place them at way stations. And essentially what it is, if you've ever accidentally set off at a checkout stand or at a retail store with the little magnetic tag, and you walk through the door before that was deactivated and set the alarm off, it's essentially just a really advanced version of that. And so these trucks would pass through, and ideally we catch some type of reading off of it, and then we can start to build out that chain of custody while also taking a reading of the current stability of that material inside that truck.
Great job.
Thank you.
Great job. Okay, bringing up Team 10. Here he is. All right.
Hey everyone, I'm Ankit Sitesh Vaidya. So today I have come up with this idea of developing an urban threat system that can be used for multi-purpose needs, where we are also using it for fintech as well as for cyber threats, where these are errors that usually happen in the panic situations. So basically, if we have seen usually when there's a stock market crash or if there are certain situations where a crowd gathers at a particular point to withdraw their money or to withdraw some kind of to do some kind of financial activity which can be taken advantage of, there are card skimming activities that keep happening. So by card skimming, I mean the card readers are, there are attackers who are going to implement something in the card readers, and these RF signals are going to be passed outside. And these RF signals are being utilized by hackers a hacker who is sitting outside in a car or somewhere at a particular distance. So no matter how much advanced technology is coming, people are only implementing new ATM machines over there to prevent these kind of frauds so that they don't use a particular old card skimming technique can be evaded. But the major issue lies in the RF signals that are being passed from the ATM, into the card attacker who is, taking out the money from it. These issues occur at multiple places and are they've been happening at multiple places at multiple locations every year. So I present this idea where a multi-purpose system where I'll be using a sensor method where the backend part is mainly managed by Python and Fast API, where I'll be making sure that an API to detect any kind of market activity, unusual market activity that is happening at a particular place. So for example, a stock market has of a particular bank, the stock price of a particular bank, which usually does not fall by 5%, falls down, and there's a unusual crowd activity that is happening in front of a bank. Now an attacker can take advantage of this situation and make sure that he can launder money from the bank, making sure that there's a panic situation at the end of the day, and people are usually tense at such situations. They try to withdraw money, they try to do some kind of activity in panic situations where attackers usually keep waiting for this particular point of time. So what my system does is, I'll start with the software part. So in the software section, I've developed an API using Python and Fast API, which integrates with certain real-time stock market feeds, which make sure that a particular stock, which usually does not fall at a particular instant, or if it is falling at that particular point of time, that gets reported into Redis. Redis is a data streamline pipeline where for this multi-purpose use case, it will be making sure that both the stock market decline as well as a panic situation gets properly streamlined together in order to make sure it goes to the dashboard. So once this is done, in order to verify that there is no false positives or something, there's a threat detection engine which is making sure that this threat is being identified and made sure that there's maximum possibility of that particular event to happen. Now, who are the losers in this particular point of time if such attack happens? It's either the banks or it's the stakeholders of a particular stock. So what happens is, after this system is being implemented, Twilio API is being used. So send message queues through MQTT, and what happens with that is the queues, it's gonna be sending both the SMS alerts as well as it's gonna be updating on the dashboard, the React dashboard that I have, in order to make sure that a particular issue does not happen again, and the municipalities are being reported about this particular issue way before that the news leaks out, so that most of the stakeholders are not at loss at their particular moment, and even municipalities know that a particular attacker is trying to do such an activity, and card fraud or something like that, money laundering fraud can be avoided. Yeah, the target audience I've just mentioned, and these are some of the technology stacks I've used, and yeah, thank you. Any questions? Can you be a little louder? Can you be a little louder? I heard cryptocurrencies. I was able to hear cryptocurrencies, and then
Yeah, so the big issue in the cryptocurrency space is fraud. So how would this idea be able to address that? Would this be able to address that?
yeah, maybe I'll have to just make sure I have another model implementation for it. But this is more of it is more of focused on the urban crimes to get evaded, as well as the stock price decline that has to happen. Usually, financial stuff, everything is dependent on sometimes the stock market crash, and people get in this panic that they've invested a lot of money, and then there's a panic around where usually these panic situations are the time that attackers are waiting for to take advantage of the situation. So currently, yeah, I just have to implement one more model where the cryptocurrency criteria is being implemented, and this can be done for that too. But that's a complete online part, and there'll be no sensors for it. Yeah. Sure. Thank you.
Thank you. All right, so how many hackers here have participated in another hackathon before? All right. Is this set the gold standard of hackathons? Oh, yeah? Well, let's thank the leadership at Code Metal for putting the bar pretty high for our first hackathon. going to go with Team 13.
Hello everyone. I'm Strahinja, this is Eric, my roommates, and we're here to present you our idea about Ghost Grid. So when we were coming up with this project, we knew two things. And the first one is that our city and our country has really good operators and first responders, and in order for them to conduct their mission, they need to communicate well. So we did some of the market research with the operators we knew, the Navy SEALs, and they were saying that they have a lot of problems with the current communication. And they were mentioning problems like jamming, range, coverage, dead zones, or some other kinds of different problems if there's a disaster that happens and their cellular goes off. So in order to solve these, we thought, how can we tackle this problem efficiently, utilizing strengths we have?
Yeah, so one of the things we want to focus on, and this ties back into the overarching objective of the hackathon, is how do we utilize public infrastructure and strengths that we already have? How do we turn these into tactical advantages for our operators? So the first thing we want to do was look at what existing solutions exist already, and what we found was things like Meshtastic, Painless Mesh, these different mesh network libraries that you could download and use. They only either use LoRa or they only either use Wi-Fi. So what we contributed was we developed a Ghost Grid communication algorithm which is able to integrate automatically with public Wi-Fi infrastructure which already exists. And what this allows us to do is communicate using dual mode between LoRa and Wi-Fi. So what this essentially means is that if a LoRa signal drops for whatever reason, whether that be jamming, range issues, dead zones, it'll seamlessly switch over to using the Wi-Fi infrastructure, and that allows us to have seamless connectivity in communicating between these operators. So we have a really lightweight technology stack that we're using. All we're using is an ESP32 from Heltec, and a slight modification we used was that we took the antenna off because for the demonstration we wanted to make sure the range was as short as possible to demonstrate signal drops.
So who are our primary target audience here? It's all of you guys. It's the special operators and it's the city of Boston. Because there's a really strong dual use case here. For the operators that are in the field or in the urban area, for example, Ukraine, they can utilize this only via LoRa or via public network that they can connect to. Or in some other cases, they can relay it to a drone. So we can stick one of these devices that we are using, because they're so lightweight and cost effective, we can stick them to drones, throw them in the air and have our own relay point. And this is also useful for city of Boston because in the case of disaster where there is no cellular data, we can throw one of these drones or utilize the public Wi-Fi network in order to extend our communication. And that way we can have the reach over the whole city. This way, it's a cost-effective and scalable way to communicate. And now, Eric will explain, give a really quick video demonstration. Yeah, this is the idea I was talking about, the drone, where you can use it as a relay point. So in the video there, I don't know if you guys all can hear Eric, but right now we are utilizing we are communicating over LoRa, so close range, these things are communicating with only LoRa. Then I will take one of the devices and walk with it across the room, which there is no LoRa range anymore. So in our showcase here, see, you can see me here walking. Yeah, in our showcase here, now the range that there is no, we are communicating to Wi-Fi, and all of them are being able to relay information between each other, even though they are not in LoRa range anymore. After that, we showcased that if you come back, it self-heals, which was the main point. Thank you. Is there any questions?
There's one over here.
Oh, yeah.
So it's not utilizing Meshtastic, you said. What? Is it utilizing a certain framework that's open source or anything?
No, we actually saw Meshtastic through our research at the beginning, but we decided to develop our own framework, which took a long time, and our own algorithm of routing. So we are completely framework free. It's our own building blocks.
Great job. Great job, great job. It should be noted we have teams that have flown in from all over the country, which really speaks to the support of SOCOM and everyone involved, our partners, J2 Ventures, Fulcrum, J2 Partners, and Shield, just getting the message out. We really knocked the cover off the ball with who we attracted and the talent that we attracted. Team Sensor Placement Optimization Tool.
Hey everybody, we are Team NerdCom, and we designed a sensor placement optimization tool. Quick introductions, we comprise of a team of 5 active duty Army, Air Force, and Navy officers. 3 of us have backgrounds in business analytics, and 2 of us are studying finance at Boston College. So we just attacked this hackathon through the perspective of those disciplines. On Saturday morning, we were talking with some of the stakeholders in the room, specifically the AppSoc guys over there, and they were saying the difficulties of deploying a sensing grid for an actual objective. And so we wanted to develop a system or a software tool that takes a data source that's relevant to the objective and a map and find out where exactly to place the sensors within that geographic area. Take, for example, the Boston Marathon finish line in Back Bay. This is important because there's no current established sensing grid there, and the crime in Back Bay is something that could be used to inform where the sensors should be placed.
As Team 3 talked about in their project where they had these sensors that they placed and they worked, they didn't necessarily talk about where to put them. So this is kind of where our project can fill that gap. One thing we looked at in terms of literature was past sensing grids that were done for undersea warfare. In order to do this, they broke up maps of the water into different grids. In each of these grids, they were wondering if they should search there or if they should not, based on historical traffic patterns. Much in the same way, we're doing the same thing with the urban environment. We take open source data, such as the OpenStreetMap database, which is a bunch of community-made maps associated with the streets of cities all across the world. So it's not just domestic in the US. On top of that, we took the Boston crime data in order to better understand, okay, what is the distribution of crime across a certain area of Boston. We had to do geospatial data processing, and then we made the optimization model in order to understand where we should place each of these sensors. With this, we had to define our variables and our search areas as well. So to do this, like I said, we used OpenStreetData and a Python package called OSMNX. This allowed us to create graphical representations of the streets in Back Bay specifically. I don't know if you can see too clearly on here, but the blue points are potential spots where you can place sensors. With this, we then had to create a 50 by 50 meter grid. So we had enough granularity to understand the reach of the sensors, as well as understand the crime in each of those 50 by 50 meter grids. After that, we then had to figure out what is the reach of these cameras. We set them in our model to about 75 meters. So this gives us the max range of each of the potential places where we could place these sensors. After that, we then put the data into the model and we understood, okay, based on if we were limited to only 10 sensors, whether it be to actual sensor constraints like Team 3 talked about, or the number of people that can monitor those sensors, we need to understand where the most risk is. So based off this is how we understood the coverage of the areas and what made the most sense. And It's really cool because it ran really quick, so it should save people a lot of time.
Yeah, and so lastly, usually in business, it's good if the project you're undertaking actually makes you money, right? That's a good thing. And so what we did is we analyzed a comparable contract that the DoD and AFWorks released a few years ago. And all that's to say is that, Mr. Morales, this will make you money if you hop on this bandwagon here with developing something like this for Code Metal. So now that we got the big thumbs up from the money guy, let's wrap it up here. So this spot essentially helps us understand where to optimally place sensors in a deployable temporary sensing grid, and it helps Boston officials and soft operators alike. It increases situational awareness, increases efficiency, and decreases risk to do so. Thank you very much. We'll now open up to questions. Yeah. Thank you.
My question more about the mapping aspect.
Yeah.
So I'm curious, so in the crime map specifically, I'm not familiar with the database you used for that, but my question is about your considerations around filtering that data, specifically around sort of implicit and historical biases within that sort of realm of map.
Robbie, you want to take on?
Yeah. That's a really good point. Again, the whole idea of what we were doing here was more proof of concept. So we were looking for a data set that was open source that would kind of apply to our issue. We just wanted to make sure like it would work relative to whatever data you have. You're right about that. There is bias in those things. So that is something you could filter for with more parameter or more parameters, more data you can take in. Yeah, that's a really good point. Thank you. Yep.
Like data sets out there that will allow you to see like what's already been deployed in a city. Like you said, it's if you're prone to for like optimizing where to place the sensors, but let's say you're on an existing city with equipment. Can you see that through some kind of source? It's classified.
Yes. So yeah. Frankly, yeah. So one of the reasons that we wanted to make Spot like a framework and a tool that can be used in different environments is that a lot of that data actually is behind some sort of firewall, some sort of classification level. So if we hand it over to the Boston City officials, if we hand it over to Soft, they will have the proper data that they can upload into it to help inform their decisions.
And yeah, on top of that as well, you're right, if there are existing sensors, you might also want to know which one should we monitor more, right? And that's one of the big things. You're having an event going on, let's say like, the president's coming into a certain area, there's probably cameras there, what do you monitor the most? This can kind of help plan for that.
Great job, guys.
Thank you.
Thank you.
Great job, guys. This next presentation is a team from Tufts University, 21st Century.
Also a Windows user, sorry.
All right, you need the non-tech guy to figure this out for you guys? All right.
I prefer Windows.
All right, there you go.
Arizona State University, thank you.
Hello, everyone. I'm Douglas.
I'm Adam.
I'm Charlotte.
And I'm Dan. Adam. We are students from Tufts University, all engineering, and this is our project, 21st Century. So this is sort of a brief overview of what you'll see. Nice photo of our campus.
Yeah, so the problem that we're trying to address is in modern warfare, the use of drones have become increasingly prevalent, as we've seen especially in the war in Ukraine. And especially the use of cheap civilian drones in urban areas, as we can see from the threats in December with the New Jersey drone sightings. And we want to be able to track these drones, especially in the airspace where there currently isn't a lot of tracking. Radar can be difficult to use on such small objects. Yeah, so we're trying to use existing infrastructure within the city. There's already many microphones in an urban environment like Boston. For example, we have gunshot detection, we use shot spotter, and there's an expansive map of microphones. We also have, I believe, 35 noise pollution monitoring stations, which also have mics at them. And then we're also would be planning on mounting audio receivers on key locations, like areas where we think an adversary might want to target.
It's a lot of noise. So currently, what it would look like without any solution is you have a drone that is an enemy asset and friendlies in the area don't have any idea where that is. But with our solution, we have a audio object array that picks up the noise of the drone, and then from there, it relays that information to friendly forces, alerts them, and then from there, they can take cover and maneuver as necessary. And then from there, knowing that position, then they can have increased mobility in addition to decreasing enemy access in our airspace, as well as decreasing their maneuverability.
So a little bit about how we're doing the drone detection is we're using very inexpensive, like $50 microphones, which are omnidirectional, and pretty much we're doing no ML, no AI or anything like that to process it, because that causes latency. And we have very simple digital signal processing from each one. And then from there, we're using something called beamforming to figure out the kind of relative direction and position magnitude from each node. We're, in our case, we did testing with 4 nodes. We were able to use some very simple Python script, which has very low latency, set up a small grid of microphones, and effectively get 3D mapping of the probabilistic position of where a drone could be. So here's another version that uses a heat map, and there is basically the ability to view all across the region that we set stuff up.
Okay, I guess I'll go. I probably don't need a mic. The scalability aspect of this is that instead of just audio, because it diverges, we can use radio, which I'll demo a little bit. And it already works. Yeah, and another thing is like the audio doesn't have to be really synchronous. We have our algorithm to figure out the sync. So basically it's almost like a phased array. Imagine a radar just with an antenna the size of the whole city. And yeah, like right now it's still, we have a setup that's sending data to my laptop at the moment. So basically we're saying the data can come from remote locations. You don't have to be hardwired. Yeah.
So for scalability, we're here in lovely Boston, my home city, and so as Alan's explaining, right, we can pretty nicely enlarge our system, thinking about strategic locations across the city. Right, obviously there's the Hancock Building, the Prudential, even a Coast Guard station down at Pacific North End. Yeah, thank you to everyone. But,
Questions? Yes?
What density of microphones do you need to effectively triangulate? And when you're installing new ones, would you do them in pairs, or how do you see that?
So typically the sort of method that we're using in interferometry is pretty much using 4 to determine a position in 3D. And pretty much what we would do is we would have these clusters of like 4 nodes, and it can scale up. So we have 4 on one building, 4 on another. And this would pretty much inform a greater sort of mesh grid of where objects could be in the sky. Yes?
How do you mitigate spoofing?
Spoofing, Al? Do you want to talk about that?
Yeah, so basically we are hoping to not just use the beacon. It's definitely not going to be based on amplitude, because all kind of microphones among the different cities, they're not going to be the same. So the only information we're extracting is from FFT. And that information can be fed first through a filter, then to a machine learning algorithm. In our case, I just want to demo really quickly. If I turn it down, you can clearly see it's a little delayed, but you can see like a clear signal change on the right side of the slope. Right now, I'm turning it off, it's coming back to black. And the interesting part is when I'm turning it on, no matter what kind of control I'm doing, or no matter what kind of data it's sending out, the feature is actually about the same. So that is the feature set, which we are going to truncate to 0 to 20 kilohertz as the audio data feed into the existing audio classifier, and that will be used to distinguish
an actual drone versus something else.
Similar to that, how do you mitigate the effects of echoes, or in an urban environment you might have noises amplified?
Precisely, exactly the same. Because once again, it's not just tracking for the maximum strength or, for example, a certain frequency. It's not even like a number that's the output. We're basically feeding something as a audio stream directly into our classifier, and it's gonna output hopefully with a confident score of like whether there's a drone there versus not.
It creates a heat map, so wherever the heat map is the greatest is pretty much the most likely position.
And this problem has been addressed with the gunshot detection. That's prevalent in many cities. So it is definitely a concern, but something that's able to be addressed.
Great job, guys.
Cool, thank you.
Thank you.
Okay, next up is Team 20, Titan, with Urban Noise Reduction Systems.
Thank you so much. Hello everyone, good to see you all. So we are Team 20. So before going into what we build, I just want to ask you, did you guys like this sound? Oh, I think there's no sound, okay. It's fine, it's like just a very busy city. So I'm sure like most of you guys don't like the sound of busy cities where there's a lot of engine sounds or the car horn sounds, right? So we are trying to build an urban noise reduction system, which is an advanced AI algorithm based noise reduction system, which is trying to create noise reduction zones. The growing challenges of urban noise these days. There's a lot of health impacts, urban complexities, and the current solutions what we have are very limited, like noise barriers and etc. Why urban silence? Why now? Transforming urban livings, increasing population, urbanization, and of course that leads to a lot of health issues due to noise pollution. And advancement of AI algorithms have gave us a chance to actually build this model. Looking into the market opportunity, sound mitigation market is, the global market is around 20 billion, and our system focuses on around 10 billion. And according to a report from WHO, 40% of the Europeans expose that traffic noise levels are above 55 decibel, which is a harmful number. So we were trying to understand why this model is still not built. So there was a company called Muzo who tried to build an active noise cancellation system, but that was one of the biggest failure of this company. So instead of like cancelling the sound, they was actually amplifying and creating a lot of noise because they used a single speaker and a single microphone to solve a very big problem in an open environment. So our system is trying to convert the open environment into a closed environment and trying to create zones where we could reduce the sound. You want to add any point?
Yeah, we also take care of the cost of the microphone. So we place the microphone strategically so that spacing between the microphone should be less than the wavelength, the half of the wavelength of sound. It's basically we try to cover as much as area possible with minimal number of microphones.
Yeah. So looking into the competitive advantage, whatever other solutions we have like noise barriers, noise cancellation headphones, or urban planners who's trying to build on cities in such a way that noise creating things like factories or something should be away from where people are living. So I think our system has a better advantage over there. So this is how our system architecture looks like. I'll go into deep one by one. This is where microphone array and signal conditioning is happening. Next is digital signal processing.
Yeah, so dealing with sounds is a very tricky thing. So we need to understand the sounds. We know the sounds as amplitude and other things like spectrogram. We did
all this kind of processing, and then we pass it all this pre-processed sound to our AI algorithm. We train two types of model. One is basically the wave to wake. It is by Meta. We fine-tune that with different urban noise, and another one based on the pre-tuned. And we have an agentic workflow which can just detect that and pre-process the sound, classify the sounds.
Yeah, so next is we try to generate the anti-noise signals for this, and there's a user interface and the data collection. So yeah, this is pretty much about our system, and these are some of the use cases for cities and the military.
Anyone have any questions for them?
Sorry, I wasn't able to see the use cases, but I think the idea of canceling signals, in a variety of ways could be pretty interesting and useful. Could you give me an example of how one of these use cases that you can see being applied here?
Yes, there are a lot of use cases. If we talk about, there are a lot of use cases where we could create safe zones in the hospitals, or we could create safe zones where it is really required. And in the military sector, we could even create it for the drones as well. So I think in the future technologies as flying cars as well, one of the biggest reason why flying cars have a demerit is the high noises what they produce. So I think this system can actually help there also as well.
So there's another fun use case. Suppose there is a concert and we have some time limit to stop that concert, but if you have installed that, we can have all night through fun. The other people won't have any problem.
Yeah, so this is.
Yes.
I also have a question related to these cases. So, what are the advantages of this particular project compared to simply putting up a physical barrier like foliage or an additional wall or partition between you and the noise source?
Yeah. Actually, we are not trying to put a proper wall. It's more of a sound reducing zones. So for example, we have installed this system around the campus of a hospital. So once the people who are inside the hospital, who's in and around the hospital, they'll have the level of sounds less compared to who are outside and where there's like busy roads or construction going elsewhere. So, yeah.
Or let's say it's a park where we don't want walls. It should be. Okay.
Were you able to test it at all?
Yeah.
Yeah, we have a demo. Another use case could be in military, you can't actually put a silent zone for a drone. However, if you install the system on a drone, it can get as silent as it can. And say a park, you can't build a wall to a park. You can actually create a silent zone by strategically placing the system. Okay. So this is pretty scalable as well. So.
What is the maximum, I suppose, area of the room? How far can you be from the unit itself? Because at some point, aren't you're hearing the sounds 50 milliseconds later, and if you try to cancel that out, you can't cancel out that far.
Yeah, that's actually one of a very tricky situation we actually faced. And we actually need to use different frequencies and different wavelengths to actually, solve that. And say if you are considering this room, probably you will need one set of systems, and say there is something which is even smaller, probably you will need less or a different position of the same thing. So it changes with respect to where and what your requirement is.
Also adding to your question, yes, it could differ if you are standing near to our system and if you are standing away from our system. So that's where our first problem was. So if you are standing near to one, so that's how we place our speakers and microphone strategically, so that we create a silence zone, and in that silence zone it's completely nullified, and if you go as far as you go away, the sound level will increase it normally.
So,
I wanted to just check up on this product, like up on the use case. So if it's working or not, so like that's possible. Demo of this thing.
Okay, 1 more minute, guys.
So basically, like in the normal situations, there is the traffic, and also we need to keep some of the emergency sounds, such as the emergency sirens. So we can't just mitigate that. So let's say this is some of the sound which we have captured through this node. Here we can see there is traffic and also the emergency siren. Alright. So using our algorithm, we have dampened the sound, which is not needed, and we have also just kept the loudness of the sirens which are there intact. So this one is the processed audio. Here we can see that just the siren is dominantly heard, and rest of the traffic noise is dampened to a certain extent that it can't be differentiated as such.
Just to summarize to his point, we are trying to reduce the sound, but we are also keeping in mind the important sound should it be reduced.
Great, thanks guys. All right. Our next team is Project Smart City Radar Interference Mitigation Hackathon. Connor Dirks. Connor? All right, great. Well, we enacted some safety protocols here finally, so on the left. What team number are you?
We were at 8, I believe.
Okay, so this is team 8 for the judges?
And then we transitioned to radar tag from that.
Excellent.
You want to play more about what it is?
Okay, pretty good.
Yeah, mine's dead, so it's all you. Flip the, just turn the mic on. There's a button on it. Hello?
Is it working? Yeah. So we're Team Radar Tag. I'm Connor, and this is Morgan. And we're going to show a live quick demo of our product.
Yeah, at the last minute, Jacob convinced us to do this. We weren't planning for it, but we have probably like the biggest hardware here, these antennas. And so we paired them with FPGAs and used like software-defined radios to amplify the signal.
So in our demo, Morgan's the receiver, and I'm the transmitter. So in theory, I could be someone like out in the desert lost, and Morgan could be someone looking for me and trying to find my signals, and you can run your...
And we don't rely on Wi-Fi, cellular, anything like that. It's strictly offline. And so this is
Yeah, but yours was showing the base level on the show.
yeah, not looking good right now. When I like dropped it, it may have disconnected. It was working right over there. Let me just try one more time.
My script's not even triggering either.
We could have another team hop in and we could debug if that works.
Ours is definitely very demo heavy.
Is there a... I can show up the GitHub repo where there's screenshots of our thing though. Let's see.
So what our device does is Morgan's would be a receiver sitting there, and it would show the transmitting signals at a low level, and then once I would start my program, it would start triggering high spikes in radio waves and allow you to figure out these are very directional based radars, so it could help you focus into a certain direction as to where your possible person missing is.
And so here's an example where the signal's pretty low, but then Connor gets out of the elevator, and all of a sudden it's much stronger up here. This was when I was live receiving and Connor was beaming a signal. And for line of sight, this is critically important. We'll have a much better signal if there's line of sight. Connor was beaming a sine wave the whole time, but it can get obstructed by buildings and also distance, the signal weakens. And so we can see in the elevator it was pretty weak, but then it got a lot stronger when he emerged.
Yeah, and with these radars, we were even able to see, so the plan was that I was going to run outside, we were going to demo it from me outside, because we were able to see direct radar waves coming in from even extreme distances like that. Unfortunately, something happened.
Yeah. I guess any questions? Yeah, good question. So Jetson Nano, that was like $250, I believe. We ultimately didn't use that. We used the Pluto add-on FPGA, which is around $150. Do you know how much the antennas are?
They were $18, I believe, each.
Yeah. So total cost around $200. So yeah, not too bad, especially because you don't need a cellular service for it. We imagine this could be used in rescue missions. Someone that's down could be beaming a TX signal, and then rescue people could be using their RX antennas to be able to find out where they are.
Good job, guys. Great job, guys. Next team has a project Code 3, and we have just 3 more presentations. What do you guys think? Pretty good? Yeah, all right. You guys have been up for 24 hours, so, all right, you ready? I'm close. Arizona State University.
Thank you guys. Imagine you're a police officer coming back from a gruesome 12-hour graveyard shift. And instead of going back home and enjoying a hearty meal, you have to file 3 hours worth of paperwork. This is what happens to millions of police officers every single day, and this is what we at Code 3 hopes to solve. We hope to turn body cam footage into briefings in seconds. Law enforcement are struggling. The time spent on paperwork it's around 40% of each time on their shifts. And there's excessive overtime costs. Officers log approximately 18,000 overtime hours in 3 months. And also there's a transcription inefficiency. They're practically filling out for half of the reports the same information about themselves or the location or the metadata or wherever they're at. So Code 3 is a vertical solution for law enforcement. So we have the hardware that ingests geolocational, inertial, visual, and audio data. We have our in-house vision language models that I'll explain later, which can be used to semantically parse videos, and a structured report that's generated and stored securely. So here's a tech that we built in this hackathon. So we use COG VLMs, which are vision language models different from CV or computer vision models, alongside with a Stanford paper, which provided a data set. We use Whisper, Next, and Replica for our backend and front end, and we also use PDFlib to kind of integrate everything to generate the report. So what exactly we built is the event analysis, the audio transcription, the keyframe generation, and a report filler that's in our backend. And so I think what really will drive our point forward is a little demo. And so for example, for Officer Torres, this is online by the way, and this QR code is a YouTube link that shows you exactly the body cam footage that we're processing right here, in case you guys want to scan this. So for example, Officer Torres is currently on this patrol. He is stopping the suspect. So after we parse through the analysis, we're able to generate 24 independent events, analyzing 1,081 frames. And then from this, we see that specifically at, let's say, the 12-second mark, we see a detainment. And then if you go here, you see arrest procedure. From 9 seconds to 14 seconds, we see that suspect was placed under arrest in a procedure lasting 0 seconds because it was probably like a millisecond or half a second. And the officer maintained control of the situation while ensuring the subject's rights were protected. So this is everything that it was able to parse through in this 5-second clip. And we do it basically for every single 5-second chunk within this video. Again, we see in the 21st second, we saw a search execution in which two officers pat down the suspect. What's really cool about using VLM models is that they just understand semantically what's going on compared to regular CV. If you use regular CV for this, we tried this earlier before, you're just gonna see 2 police officers and a bunch of police cars. It doesn't really understand what's going on, but because we used the VLM, we were able to fine tune on top of that and prompt on top of that, we were able to understand exactly what's going on in this situation, which can be really useful for police officers. And so we have 1 minute left, so again, another case example, at 51 seconds, we saw another arrest procedure, which is true. And then we were also able to provide an event timeline, which basically is a systematic kind of approach to what happened in each incident report. And we were able to generate keyframes for RTCCs or real-time crime centers, which are super, super helpful for detectives to try to sort out crimes. We also reduced the time for reports, for filling out reports like this. We basically connected to the PDF application, and it was able to very promptly generate reports. I think last thing I want to talk about is the market for Code 3. So there's a $36 billion market for domestic tech automation industry. There's 18,000 police departments in the United States alone that need this type of service. Thank you. And then we also want to target local departments, pilot out individual users, and we also think that this can be used for the military as well. And this is our team, our wonderful team. And then if you want to see our demo, there's a QR code here with the demo video. And then we also have all of our code on our GitHub. And we're open to any questions.
What team number are you?
We're team number 7. Team number 7. Yeah.
Vision model are you utilizing?
We're using COG VLM v2.
So you showed both local examples, and I was curious, you briefly mentioned a military possibility.
Yes.
Do you see any issues in scaling that from local to state to federal to military?
Yeah, no, we see a lot of use for this technology on the federal level as well. Custom Border Patrol wears body cams. Before Biden left, he signed a mandate for the FBI to wear body cams. So we think this is something that could scale really well.
2 quick questions. Did you test in anything where protocol kind of goes sideways and see whether or not it generated a hallucination towards protocol, which that model does? And the second one is, can you talk a little bit about costs for compute?
Yes.
Yeah, in terms of like weird and odd scenarios, we found this really humorous clip of a body cam footage of this kid calling the police on his mother because she ate all his ice cream, and it was able to detect that it was just a humorous scenario and wasn't anything serious. And in terms of cost,
Yeah, so in terms of compute, we ran this on our replica server, and it only costed roughly $4 for this whole hackathon. And then I think if we were to host it on something like GovCloud, of course, we talked to some CoMetal people here, it's going to be quite expensive. And so I think our beachfront's probably going to be targeting police simulation companies, defense simulation companies to try to get that data first, so we can accredit the capital to kind of fund that GovCloud from AWS.
Great job, guys.
Oh, one more question, is that okay?
Yep.
As you generate events over time, how do you handle, so you understand video, how do you code the events before?
Yes. Okay, so I think this is I can first answer and then Dylan can answer as well. So basically one of the key insights I think for this, it's actually super important is we basically overlay chunks of video on top of one another. For example, let's say we want to take a 20-second video and we want to split into 5-second chunks. We're not just gonna have 4 chunks, we're gonna have 8 chunks. So at the 2.5 second mark, we're gonna have another video that's transformed from 2.5 to 7.5, so that we make sure that at least 50% or roughly 50% of the video is understood by 2 chunks, so it's able to understand truly what's going on.
yeah, I think the key insight here is that we're using overlapping windows of context, and we're caching each chunk so that we can actually achieve kind of this global context layer that is able to understand the entire video and not just what's happening locally.
Great job, guys.
Great job, guys. So we are broadcasting this event. We're telecasting the event to members of the Department of Defense, SOCOM. So welcome anyone who is watching this. Our next 2 presenters have some sensitive information. So we're going to go offline and go black. So those of you who are watching, in about 20-25 minutes, we'll be back online with the award presentation and some other great information. So I need a thumbs up when we go offline.
Air Force as we go. So this is going to be a trailer that shows our progress so far. As a reminder, this is in context of wargaming and Air Force futures design. And it's going to help like the relevant personnel make better decisions in the case of live warfare and also futures design in the department. Okay, so let's go. That was really cool. To walk through what just happened, we were running through the scenario of a engagement in the South China Sea in the Indo-PACOM theater. And basically within the video game, we would be able to play through multiple scenarios and finally be able to kind of like teach the family business without having to only rely on, let's say, PowerPoint slides to explain a scenario, different types of engagements. We're also working with the Wargaming Committee in Air Futures Design to kind of bring some of this like a better simulation of what happens in a potential scenario so that they can better prepare for future scenarios. So that is all. You're welcome to ask more questions. Very happy to have shared this with you, and thanks for coming to our hackathon.
Thanks, Joyce. So it should be another 5 or 10 minutes, and we're going to announce some winners. Who thinks they have the winning project? All right. Yeah. All right. $10,000. All right, guys. About 5 or 10 minutes.
I hit you in a leg, can you fit me in your plans?
About time. All right, gather in. So first off, again, give yourself a round of applause. Working your tails off for the last 24 hours. Seriously. You guys made this hackathon the best ever, and it's not going to be the last. We want to give a special shout out and thank you again to the United States Special Operations Command for just providing so many resources to make this happen. Our valued partners, Fulcrum, J2 Ventures, Shield Capital, the City of Boston, the Steel Group, Mass Robotics, JP Morgan, Rebuild Manufacturing. Again, it takes a village. It was a great, great event. And I want to thank everyone for just staying extra long. It's been these guys put a lot of effort in, and I know it's going to be a busy Sunday for everyone. So the winners are, with the second runner-up is Team 9. So give a round of applause to Team 9. All right. So the winner of the Code Medal, Metalot Smart City Hackathon. I'll go runner-up first. Runner-up is the Code 3 project. All right, and so I'd like to welcome to the stage Peter Morales and Alex Showalter Booker to present the grand prize, first place, Team 3, the Lantern Project. Come on up here, guys. Did a great job, everyone. Seriously, another round of applause for everyone involved. Good job, guys. And I'm going to hand it off to Peter Morales to say a few words to take us home. Oh, here's your giant check. You got to catch that. All right.
Thank you again. Like Ed was saying, all the hackers worked really hard. We have 2 honorable mentions. Octavian, actually, do you want to come up and mention those? It was an incredibly tight voting process. Like there was basically there were 2 folks really close to top 3 we wanted to call out.
So 2 teams came within 1 point, tied for 4th place. So again, honorable mention is the Spot Project and the Sender Project, tied for 4th. Came within 1 point. Again, great job, guys.
Really, we wanted to make sure everybody got to show their work because there was so much solid work. So again, appreciate you guys staying the extra time. It was an awesome opportunity, and I hope the teams had a good time. Yeah, they did great work, and everybody got to present, and we're real happy about that. So thanks for coming.
So I did want to point out, originally we weren't planning on having everyone present. We down selecting beforehand, basically, and then having maybe 6 people present. But just walking around, talking to people late last night, seeing all the really cool projects and really impactful stuff, we just had to change it up and make sure everyone could present, because you guys all did really well, and we're really working on some really interesting and amazing things. So thank you again. Stay tuned for, we're planning on doing one of these again in the next year at some point, maybe even sooner. So stay tuned for updates on that. And we're always hiring, so if anyone's interested and want to talk to us about potential opportunities, please come up to us, and any one of the staff has asked some questions about that. But yeah, thank you again, everyone.